Okay, so in this video, we're going to talk about residuals and least squares regression line. It's only 1, 2, 3, 4 slides, but this one's going to take us a little while. Now, the concept of this one should be pretty intuitive, but I'll just kind of go over it. In residuals, there's something called, in most cases, no line will pass exactly through all the points in the scatter plot. In most cases. Sometimes you get, the line actually passes through 1 or 2 points, which is great, but in most cases it won't. A grid regression line makes the vertical distance of the points from the line as small as possible, which is what is going on in this picture down over here. So a residual is the difference between the observed value and the response variable and the value predicted by the regression line. And it comes with a formula. And this is the one that I really, more than anything, need you to understand what it is. It's always going to be your observed minus your predicted. So your observed value minus your predicted value, which is what this one is right here. Now, it really is the distance between something. So I'm zooming in really quickly so you can see. Let's say this point right here, right? There's your line. It's how much is this distance that goes right here? That's the question. Okay, so what is this distance right here? What is this distance right here? What is this distance right here? What is that distance? What is this distance? So that is the residual, the vertical deviation from the line. Okay, so you can calculate this for anything. And in fact, we're not going to do it by hand because it would take forever. But for some data points, your calculator would do this for you, and you can find it really easily. Okay, now. How this actually applies to us goes back to takes us back to the same data point for the Ford F-150, the miles driven versus the price that you've paid. Okay, and the question is on the next slide: find and interpret the residual for a Ford F-150 that had 70,538 miles driven on it and a price of $21,994. So right away. This was the actual mileage, right? And this is the actual price. All right. So what we need to do is calculate the residual, which means observed minus predicted. That's what we want to get to. So we have the observed. Okay. This is the observed value. You have your miles, so that's good to go. What you need to get to, eventually, we need to get to the residual. I'm just going to put it on the side. The residual is your observed minus your predicted. Well, we don't have a predicted yet. We just have the observed. So in order to get the predicted, we're going to have to use the same thing that we did in the previous video in our regression line, right? So step number 1. What was that equation? The equation was p hat was going to equal, 38257 minus 0.1629 times x. That was the equation. So we want to get to the predicted, right? The predicted value for our truck with 70,538 miles on it. Okay, well, the miles was going to be your X. This is the same process we did in the previous one. So P hat, or price, is going to be 38257 minus 0.1629 multiplied by 70583. So our price is going to end up being what do I have? 70583. That, and I get a predicted price of 26,750. I'm just gonna go with 26,759. Okay, I'm gonna drop the cents off. So that is how much I am predicting that if I take this car in at 70,000 miles or 70583, I should actually be able to sell this car or get something around 26,000 for it. But I really only sold it for 21,994. So the question is, what was the difference? And that's what the residual is. It's just, what was the difference between what you observed and what the actual prediction was? Were you undersold? Were you oversold? Like, what was the amount? Okay, so we're going to do that as, so residual. There's an I in there. I'm so tired. As ID. Okay, your residual is going to be your observed minus your predicted price. So your observed was 21,994. Your predicted price was 26,759. Sorry, there you go. So you have a residual of whatever that amount was. 21,994 minus 26,759. Somewhere around -4,765. Okay. Well, that's not the end of it, though. You still need to write a sentence for this. Okay, so we have, well, let me just make sure that we do the sentence correctly, because I don't want to tell you something funny. Okay, here we go. Here is your write-up. The actual price for the Ford F-150 with 7,583 miles is $4,765 lower than the actual predicted price. Then the predicted price. Anything else we want to add? No. Okay. All right. Done. Okay. So that is least squares. Well, that's residuals. It really shouldn't be least squares regression line, but it's more along the lines of a residual. So how do you find it, and then what do you do? How do you calculate it? Okay. And then the least squares regression line I'm going to show you this, but hopefully it makes sense to you. It makes sense to me. It's just kind of a trickier concept to understand. So the least squares regression line is generated in a certain way. So your computer or your calculator will do this automatically for you, but you need to kind of understand how they're doing it, or why is that line the best line possible. So basically, different regression lines produce different residuals. The regression line we want is the one that minimizes the sum of the squared residuals, and that's when you know you have the best line possible. Whatever is the minimum of the sum of the squared residuals. And what it's doing is this part right here. So each of these dots are going to give you a residual, right? So we found on the last one it was around 4,675. So a truck with around 78 or 70,000 miles, it sold for around 21, right? So came under what the actual predicted was. Well, if you take this line right here, which is 4,765, and actually just kind of make a square with it. So it's really 4,765, 4,765, 4,765, kind of all the way around. And you take the square of that, right? That's going to give you a positive value, or the area in this square is going to be 22,705,225. Well, if you do this with every single one of these data points, based on how far away they are with the residuals, you can actually just sum all of the areas of the squares and get an actual number. Well, the best line possible is the one where if you take all the sums of these squares, this number is the smallest number possible. That's really what it is. And that's how you know you have the best line. So if you take all the squares, you add up all the areas, and then you get the sum for it, however you want to position the line, so that the sum actually comes out to the smallest number possible. It's never going to be a zero unless, you have data is in perfectly linear order. But so that numbers is the smallest possible. And that's usually how they calculate the line. You're never going to have to do that. Your calculator is going to do that for you, or find the line for you, I should say. But you need to understand how they did it, or why it's called the least squares is because when you're finding the sum, the least sum of all the squares that you have. Okay, and then your video is based on the Ford F-150 data also. So you can use the same equation that we did in the last two, which is find the residual for the truck that has 8,359 miles driven, and the price, and an actual price of 31,891. Show your work, right? And then interpret the value of this truck's residual in context, just like I did in problem in the previous slide, which was example number 10. All right. If you have any questions, let me know in class.